it is practically impossible for us to finish this series on relations and functions without talking about one-to-one functions. Yes, it's something that we should have done ahead, right? But then earlier, but we kept it in order to do it at this moment because we believe that by now you'll be able to understand some basic concepts so that you can get into relations and functions. We will look at relations and functions mostly as machines, right? So what does it mean that a function is a one-to-one function? We say functions take a set of inputs and then give out a set of outputs. For one-to-one function, it is concerned with when from the set of inputs, each input should have a distinct output. It means that when you put one input inside, it should give you one output that no one else can give, right? So one input goes to one output, and that same input doesn't go to any other output, right? So let me illustrate that with this diagram. So you see there we have A, so these are the set of input, let's call them the X, and then these are the output, let's call them the Y. Okay, so we are mapping from f of x in this direction. So what happened is that A will give birth to A1, B will give birth to B1, C will give birth to C1. So you will see that for in one-to-one functions, what happened is this guy cannot go and have this. It's not possible. We don't do that. It doesn't happen for um, one-to-one function. So every input should have a distinct output, no other thing, right? But then how will you check mathematically? So from diagram, you can see that, okay, every input has its own distance, meaning every output has only one mother or one input. So input A1 can only recognize, output A1 can only recognize input A1, input B1 can only come from input B, right? And then C1 should only come from input C. Okay, so how do you check that? From multiple functions that will be given to you, most of them are given to you mathematically. How do you know that that particular function is a one-to-one function? Okay, so I'll clean this diagram and illustrate to you. From diagram, you got the idea that that's what happens, right? So now see, if you have it mathematically given us as f of x is equal to 3x plus 1, how will I know that this function is one-to-one function? Right? So we are going to imagine an input. So which is x is the general input, general a variable that we generally use for inputs, right? But then we are going to consider an instance where we are going to say a is a particular input. It's a variable, but we are going to consider it a special kind of input. X is standing for any particular input, but then we are going to use a f of a to mean a particular. So f of a is equal to a1 from the diagram that we did earlier. Okay, so A give birth to A1, right? Now, um, for other functions, right? If you put another thing inside, like if you have f of b, there are other functions that exist like that. That if you put f of b, it's possible to get A1 for other functions. Okay, so this particular thing, it's for one-to-one function. If the function is one-to-one function, what it means that this guy can only give birth to A1. This guy, f of b can only give birth to A1 only if A is the same as B. Only if A is the same as B. You cannot be another thing and give birth to A1 again. It doesn't happen for one-to-one functions. So for one-to-one function, if the outputs are the same, then you need to show that the A is equal to B. A is equal to B before that one-to-one function can work. That's what happens for one-to-one functions. So for one-to-one functions, we are going to grab input A, right? The output of input A should, if it is equal to output of input B, let's say in this case A1, then we need to actually compare and see if A is equal to B. If A is not equal to B, then it is not a one-to-one function. Then it's another function. All right, other functions there. If you put f of a, you get a1. If you put f of b, which is another thing, you may get a1, right? You have something like many to one functions and all that. But then for one-to-one functions, you can only give birth to the same thing only if the inputs are the same. So that's what we are going to see. So there will be input A, input B. We are going to test if the If they all give birth to the same result, when you equate them, then we should see that the inputs are the same. Let's try this example and see. So we are giving this example to solve for to check if it is a one-to-one function. So I'm going to consider an input. Let's say f of a is equal to let me replace the this thing. So we get a plus 7. Okay. So if it's f of b, right? F of b is equal to 1 over b plus 7. If this is an it one-to-one function, right? If they say it is one-to-one function, then the inputs, right, should be the same. The output should be the same, right? The output should be the same. So whatever f of a will give, f of b will give the same thing. If f of b will do the same thing, we need to actually expand and see if a is equal to b. You can only give birth in one-to-one fashion. You can only give birth to the same output if the input variables are the same, right? Okay, so let's see how we can prove that. So we know f of a and f of b. So we know f of a is 1 over a plus 7. So it should be equal to 1 over b plus 7. So you have this compared. So now let's compare them. Cross multiplication, right? You have b plus 7 is equal to a plus 7. I just cross multiply. Then I have b minus 7 plus 7 is equal to a. So a is equal to b. If you now you see that okay. So if the input output are the same, right? Are the same, then a is equal to b should be valid. So in our case, it is very, very valid, and a is equal to b. Let's solve another question. So this function is a one-to-one function because we have actually proved that the inputs are the same. That's why they give birth to the same output. So here too, I'm going to have g of a is equal to g of a should be equal to g of b. So meaning the outputs. This whole thing like this is an output. So the outputs are the same. If the outputs are the same, then what? We need to actually expand and see if a and b are the same before we can qualify this thing to be a one-to-one function. So 1 over a squared plus 5 will be equal to 1 over b squared plus 5. If you cross multiply this, you will have a squared plus 5 equals to b squared plus 5. If you let me send it up here, then you have a squared is equal to b squared plus 5. Sending the other 5 to the other side, you have this. So a squared is equal to b squared. Now, if you find square root of both sides, right, you have a is equal to plus or minus b. Remember, when we did set, right, if you are finding square root of both sides, like this, square root of this side and then square root of this side, what we are going to get is that this one can be a plus b and a minus b. So you see that a is not explicitly equal to b, but it's equal to plus or minus b. There are two components which we don't want. So this is not a one-to-one function. We need to have a plus b at the a is equal to b at the end, not a is equal to plus or minus b. We don't have that, so this is not a one-to-one function. So we just use the idea of sets, right? Let's solve this last one. Let's prove if this one is a one-to-one function. You can try it alongside with me, right? F of a is equal to f of b. If this is true, then when we expand, 1 minus a will be equal to 1 over 1 minus b. If you cross multiply, you have 1 minus a is equal to 1 minus b. So I will send the ones on the other side. Then when you do that, you have negative a is equal to 1 minus 1 from the other side minus b. So what do I have now? At the end, you have negative a is equal to negative b divided by negative 1. You have a is equal to b. So you have a is equal to b exactly, not a plus or minus b. So this is a one-to-one function. So yeah, so this now show that it's a one-to-one function. So one-to-one functions, right? They give the same. If they give the same output, then the input should be the same. If they give the same output, the input should be the same. That's about one-to-one functions. Yes, with this one-to-one functions added to this series of videos in our playlist, then you are good to master the topic relations and functions. Solve multiple questions and then let us know your challenges in the comment section. See you in another series.